Good morning. Good morning, everybody. Namaskar. Millennial to power. Millennial namaskar to everybody. This is Engineer Suraj Singh speaking from Bharat, India on this day, March 15, 2022, Tuesday, 3:50 AM. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ. आज मार्च 15, 2022, मंगलवार 3:50. आई एम प्रेजेंट यू टॉक continuation of the subject, many titles in relation to quality and coordination, engineering project works and engineers who are reliable, issue of communication in concrete, work contracts, safety, designs, construction methods, etc., etc., etc. And my email ID according to presentation is, you can see that is suraj_engineer@yahoo.co.uk. You are most welcome to write to this, whatever question you think so, or whatever comments you have. If you are interested, you can write. And this is my board, Chartered Engineer India and International Professional Engineer India. And this is certification that evidences my validity of certificate 5 years. And this is Chartered Engineer certificate issued by Institution of Engineers India under law, charter, legal charter, that's Institution of Engineers India, Charter 1935. Also, there's a membership as fellow, FIE, from same institution, which is also a statutory membership or chartered membership. And this quality file and coordination file which I'm going to discuss, and also concrete file. I'll open, I close this certificate of file, and I close this certificate Chartered Engineer India, so I can reduce value. And now also we have our file of concrete, and also you can see I can open this file also here, and that's concrete file, concrete specifications from Qatar. Concrete, which are important material, without which cannot survive, you cannot develop anything. It's actually naturally and artificial, both you can say. It's natural material as well as it's artificial material, because without it we are not anything, and we have to be very careful about. And also aggregated, etc., which are ingredients of concrete, and therefore it's very important for us to understand that. And then we can say what to do, what not to do, what to do, not to understand. So all these, and fine aggregate and cost aggregate we are discussing. So we'll be back here after some time. We'll go to coordination and quality file. Quality, which is a very important part of life, and every day I tell that I understand it. Maybe you start thinking now I speak something useful. Well, if you are interested, if you are engineer or no engineer, doesn't matter. You are a person, you are a citizen, it applies to the whole world also, quality and coordination. It's not that I'm talking about this country, though, it's issue particularly for my country, Bharat, India. The quality has actually, in fact, it doesn't exist. Very, very rarely you can say quality or quality systems. So there are so many quality systems available here. Everybody is certified, you can say every company is certified. Every organization claims that it's quality organization. In fact, are they? This question is that. That's why I put title quality, coordination, engineering, reliable engineers, communication, concrete, civil engineering, works contracts, and SHE designs. Work contracts very important issue here, and you can say disputes are also there in works. So work contracts have not been very much in details, but I include that also, because without contracts, works cannot be done. Without contracts, nothing is done in this world, in our country also. Whatever agreement we make, whatever transactions we conduct, all these are done through contracts. Maybe it's not in written or understanding. If you see, you get whatever service you get some AMC or whatever, something is written on backside of that, and that's considered contract. You may never study that, and generally happens. That's why we say something is understood, something is not understood. We'll generally think it's general, no problem, and that causes sometimes a problem. So as issue of quality is concerned, issue of coordination is concerned, both are related for me. And in this country, we have to improve. It's our duty. Being citizen of this country or work in this country, Bharat, India, it's duty of every person. Sorry. Quality cannot be isolated. And if you isolate quality, we can say we kill material, we destroy our material. Without quality, if we produce, and we also cheat ourselves, I can say. Those who don't understand quality or don't believe in this, or they say, okay, no problem, we'll manage it, and management of that is very bad. Management means something we have to do whether it's right or wrong. It doesn't matter where to do it. That's called management. Management doesn't mean truth. Management doesn't mean facts. Management doesn't mean requirement. Management is a word which is used in many ways. That you manage it. No problem. Sometimes you say. So here is I fear this word, in fact, management or manage, because it applies in both ways, good way or both ways, good and bad ways. So question of quality and coordination is very important, and that's why I'm concerned. I've been experiencing that quality is not understood and it's not applied. Nobody cares. No one. There are so many examples I can give, but sorry. Nobody cares for quality, and when you don't care for quality, this means you don't care for coordination also. When you think if you just think of links only, it's coordination, and that's not proper. Coordination means technical coordination, information coordination, and if you want to get quality, what is required to make it available or to have complete information, that is coordination. Quality and coordination, in fact, coordination and quality cannot be separated, and quality and quantity also cannot be separated. So quantity plus quality and coordination have to move together. That point we have to really understand. Many people say every day you talk like this. Yes, I talk every day because it's life. If you repeat something, it's my duty actually, because I am an engineer first of all. Then only I am a servant for someone, or I'm a service provider for something else. If I don't have intention to do good job, I can't do it. If I just keep compromising at every place, okay, sometimes it happens that because of some reason you have to compromise, and you are not getting full payment, or you are not selling a product which is discounted, and people think it's okay, and they say, okay, fine, it shall work for us in the working conditions. So, okay, fine, I'll get work. This product is useful for me. Okay, it's 60% useful, 70% useful. Fine, I accept, no problem. But to me, it suits. It happens. Now, suits is if something suits you, and you accept that, that's your personal choice. But as far as concerned, for everybody, if somebody pays that one person express, one gets what is paid for. In general, we can use English language. I am paying you this much, and you are not returning me same amount. Returning me same amount in terms of good work, in terms of expected work, intended work that I expected you to deliver to me. But it doesn't happen. And that's why I say we have to think on this kind of quality, kind of coordination. You have to ask yourself, you are a part of quality, you are a master of quality, you are a father of quality. If you don't produce this, means you don't do your job. So I say you have to get up yourself to get quality, and you coordinate yourself. For that you have to get up, you have to keep focus on something. If I need 15 information, I must get 15 information for something to do. And if you don't get that, means I miss something. This is defective work in that case. Because okay, I allow this, don't worry. I allow this, no problem. We will see something else. Let it go as it is now. Sometimes people say that. No problem, this time we have to do it, next time we'll see. No, that becomes a practice, that becomes a habit. We have to be a little serious in this. Seriousness is very important. We are not serious. Even professionals are not serious. Engineers are not serious. Doctors are not serious. I can say that very clearly now. When money point comes into mind, seriousness is dropped. Because money is more serious. Money brings seriousness. If you lose money, you are very serious. How I to stop losing? If I lose it, I have lost, how I can get back? Then you are very serious, because you think it's your belonging. But quality, you don't think it's your belonging. No problem at all. The news says doctors left Caesar during operation with the stomach. It happens. What I would say, there was some point that could not be done, and it brought setback to that quality. That's why, my dear friends, it's a very important point to get into knowledge, that we have to be very serious about this. And when I say stop sleeping in this country, hours, when I say hours, this means our country. Hours equal to our country. This is short form of our country. Hours in hours means our nation. Stop sleeping in hours. If I sleep in hours, my country sleeps. My people sleep. And sleeping is no choice. And don't think sleeping is just sleeping physically. We sleep mentally, we sleep consciously. Mentally sleeping is very bad. I keep my eyes open, I look at bird, I only see something in my eyes, I don't see everything in my eyes, because my mind is also my eyes. My conscious is also my eyes. Eyes doesn't mean these two eyes, or these through which I can see this world physically. Understanding is also eyes. So my eyes should remain open, and that is very important point from sleeping or not sleeping point of view. It's general word at international. Oh, you are sleeping, you are working. It means sometimes when I started thinking, I told the first time in life, you are sleeping, you are working. I am not sleeping. Maybe mentally you are sleeping, you are not alert. You're somewhere else mentally, but you're sitting here, you're working your mind somewhere else. And that's happens here. And if you have to befriend quality, coordination, and work and seriousness, as much as you get it, as much as you own quality standards, coordination standards, working standards, you can upgrade yourself. You say, no, I'm not same, I've changed my conduct. You not lose anything, but you lose more serious in that you understand what point what you have to do. Sometimes you ignore something. I'm taking cup, I'm relaxing to welcome tomorrow, don't worry, leave this job as it is. That tendency should not happen. My point says that you have to finish your job, don't delay it. Delaying makes further delay. One delay gives another delay. It goes on in sequence, and we lose something. So it's very important point we have to understand, we have to realize, and if we don't realize this, we cannot do anything. So I can say, be my friend. Who has to be my friend? Quality has to be my friend, and coordination has to be my friend. Stop sleeping has to be my friend, and I cannot work without this. And everybody has to think one cannot work without that. Sometimes we think it is quality and we miss something, we ignore it, and later on we know, oh, I ignored this point. That time it cannot be done. And that's what I'm saying. Keep awakened. So this is a small talk about quality, because every day I have to remind everyone that we have to be serious, we have to handle it successfully, and particularly we engineers who are responsible for quality during manufacture, during industrial activities, during construction, or during development, or during whatever do, because engineers are generally involved in all activities of physical construction, physical work, design work, theory work, research work, innovation work. They are involved. Scientists are involved. Everyone is involved. It's not simply repetition, it is something new we have to do. We have to design, we have to execute. Design and execution are very important parts in civil engineering, construction engineering, development engineering, every engineering. It's not simple mechanical work or production work we have designed one time and we will manufacture same parts for thousands of times. Doesn't mean that. But in engineering construction, in construction engineering, or you can say everything is new, every design is new, every plan is new. It's not repetition. I designed one building and I have to repeat 1,000 buildings. It doesn't happen. Very rarely it happens. Even if suppose I use same design for 10 areas, there may be differences of foundations, there may be differences of local factors, load factors, wind factors, seismic factors. Despite we have to understand that civil engineering is a kind of innovation. Every design is innovation. Every new construction is additional practice. That's why I say we require to establish permanently, that is quality, permanently in our way, that we have to understand at every work it's something new added to your career, to your knowledge. And that's why we say quality is something we cannot just understand easily, and that's reason people don't concentrate on this, even though they are very well qualified community. I cannot say they are not educated, they are experienced as well, and in spite of having experience we do not care for. That's unfortunate. That's why quality engineering and quality and coordination engineering are very important requirements, very important factors and facts for which, through which we talk of working designs, manufacturing, construction procedures, and we assess everything. We measure our values according to quality, what goals we achieve, what we do, what we don't do, and in our country we have to fix it. We have to fix quality standards and coordination processes. Both should move together. There can be given no excuse if work quality cannot be compromised. There is no way that we have to compromise just in name of because we are fulfilling quality system requirement, and we cannot say automatically quality is achieved. That is not possible. That is not acceptable. Compliance is very important. Compliance to quality procedures, compliant to system, all are required. No excuse can be granted because systems are fabricated, systems are designed, but product quality cannot be achieved automatically. We have to be very serious. And that's why we have to think of, can we bring working environment to quality and coordination requirements? If yes, how to do it? And we will be back on that. Now I jump onto another file, and that is engineering coordination and coordination engineering projects, public and engineers. As I said, coordination engineering. I tried to find many times on web, on internet, on Google, how much I can get information about coordination engineering, and I got very little information, elementary information, and I am not satisfied. Not happy. This indicates that people are not very serious about coordination, and that is throughout world. I am not saying about my country alone. Because when you search on internet, you get information what is available on pages from around world. And I can say very little, ignorable, negligible information I got, and which I did not get anything from that information except what we know. And of course, coordination is not formal. It exists everywhere. There is no formal subject. There is no formal education for this. And when we talk of coordination in every field, in every work, it is different, and it depends on many modes of communication, including verbatim writing, printing, newspaper, news, specifications, provisions, designs, and whatever is linked to works, whatever works. It's not engineering alone I am saying every work. Even sometimes coordination is missing from very elementary level, where people don't even know what is coordination. And coordination is very important because coordination means you should know what is required for some work, what information is required, and you must have that information before that work can be completed. And that information, how to get, from where to get, that is your job, your requirement. It may take some time, first time, second time, but when you are used to that, it becomes a system of information input and output one time. And then when you do some works, again the same time of work, you will first search for the information before doing anything else or something else. And that's where coordination plays an important role. Means it should be system, actually I should say. Just like we say quality is a system, I can say coordination is also a system which is undefined. Quality system is defined, procedures can be defined, but coordination cannot be defined. It can vary for every activity. And in engineering, there are so many activities in every branch of engineering, in every subject. There are so many topics we have to discuss. And really, that is a very important point from my viewpoint. Life is not what we think it is. Life is different. Life is practical. Life is not theoretical. Just theoretical. No, theory is one part of life. Theory is one part of life, practical is one part of life, and you are one part of life, and we have to consider like this only. We have to integrate all these parts, and that's what's required. We simply cannot ignore this. Ignoring means we ignore ourselves. I cannot ignore this, you cannot ignore this. That's also a requirement. So, what, my dear friends, I have to say about coordination, that it's very important, and try to understand that it's very important. I cannot say for common person, but to an extent engineers are concerned, and particularly civil engineers are concerned, because in mechanical world, in electrical world, so many activities are well defined, actions are well defined, and particularly those technicians are of course to some extent trained. You'll find those technicians, or you can say half engineers, working in mechanical engineering, electrical engineering, or in other engineerings. Particularly you can say these are actually major engineerings. Particularly IT people are also well educated formally. Mechanical engineers are well, mechanical persons, technicians are also there, indoor people, they are not outdoor people. Same way electricals are indoor people, and they are trained by their seniors in a working way. But to an extent, outdoor workers are concerned, and outdoors are construction people. Generally, they are outdoors, whether they work in buildings, they work on roads, they work on whatever field in civil engineering, they have to be outdoor, and often they work outdoors where coordination is not done by them. They may know it, but they wait for that. Somebody should come and tell them what to do, because every work is different. It's not mechanical part or spare part. Once it is designed for manufacturing, you have to produce as many parts as possible. Each every design, every work, every object is different in designs, different in construction. And that's why you cannot generalize this issue. There are many hundreds items in our activities of buildings, many items on facilities, many items in road work, though not as many as buildings. There are very few items which cannot be numbered in construction engineering and design engineering. That's why it is very important. Coordination applies intensively in civil engineering, not like other engineerings. It's only engineering where too much work is done in coordination, in designs, in planning, in construction, or you can say whatever work we do. Every day, every hour, we have to coordinate, whether it is in writing, or it is only verbatim, or it's only directionary, you can say. Without that, it's not possible. And particularly on physical works, where contracts are involved, without which no work can be done. It's very important one, that we have to understand what is coordination, and it cannot be explained by statements. It cannot be explained by some theory. These require to be done based on practical activities and communication support for reliable coordination. And that's what is very important. And if you don't understand that, no one can teach you. Activity shall demand itself if you keep an eye on that. If you run away, if you skip that moment, you shall certainly make mistakes. It should not happen. And thereby, the voice say communication, support for reliable coordination is very important. I'm not going to discuss these projects at this moment because I'm going to text of my coordination, and then we'll be back on this. Let me go to text first so that I can explain something in brief or in you can say brief, I can explain something for clarification what we have to say. And because we forget always, that is our beauty, our specific outlook, everybody forgets, and and that forgets us. Just I give an example here, coordination example. You can see this. You can see this drawing. Maybe in first instance you say, oh, what is this? I don't know. It's very complicated. I can't understand this. I can't even read this. You may say that. Yes, that is valid statement, ab initio. But it is not that. It looks very complicated. It looks as it's a big circuit of some process plant. It's not that. Of course, it is related to process plant, but as far as drawing is concerned, it's not process plant. It's simply some buildings located in this area, some roads, some, you can say, facilities like that. This is just a drawing that has been combined. First all, you can design yourself, means you make a layout, do something, or you can take various details from some project, and if they are for same project, you have to combine them. It's the result of combination of various details and also original one. But it's not very complicated. It looks big. I blow it up. You'll see that. You will say you get more and more details here. And this line work shows it's very complicated, but if you go in details, you will find, oh, it's all very small buildings, and curves are there, lines are there, squares are there, labels are there, arrows are there, sanctions are there. You can see that. Angles are shown, radiuses are written, all that on, because the coordinates are given. E and you can, there no N and E means coordinates are given, northing and easting. Same way buildings are shown, road is shown, services and all this, not building detail of inside, but just a kind of layout plan. It is coordinated layout plan, you can say. It gives you something when we have some big project and we want, maybe we don't have complete detail, but we have given separate area details, but there is uniformity in dimensions, or you can say unit is there. We can keep them on one plan to combine them. If we cannot start in beginning, start from whole to part or part to whole. It happens sometimes. Particularly civil engineering says better if you start from whole to part, because if you start from part to whole, you will expand errors, and if you start from whole to part, you can say, you can remove errors, you can eliminate errors, or play with it. You can set errors right. Well, whatever, it doesn't matter. But question is, it gives you a way, it tells you where you have done it, because these lines would not meet together otherwise. And this is a silent, or you can say commanding coordination, where errors can be discovered. They say these days we have coordination software. Well, I'm not going to that one, because no coordination can be done by software. First point is that. When human error is involved, when work is involved, when practical error, means you cannot explain in 1 second or 1 minute where mistake comes. When you search on that, move on to that, you find, oh, here's some error, and by chance here you discover. Otherwise, it's something that you will not know it, and you will keep on thinking where my point is not meeting, what's problem there. and you will hold upon your mind and you will not get anything. And that's why I'm saying it is a very important part. You must have seen this building, and there are so many other such coordinations which are done in our field, and we do that one. It's just an explanation it was and nothing else. Means if you see same thing is here, same building is here seen without any detailed line work, because it is only landscape plan, it's not that plan which I'm talking of, and it doesn't look very complicated, it looks easy. And that's why I'm saying it depends on what type of work it is we are doing. Well, now also I'm just going to text this page, and we can start. So much is written in this, and every day I cannot, some in parts I can tell only what is to be done, and but I'm coming to concept of this, and that's coordination engineering, and which is a must on every project, and without which we cannot do anything. I can say only we cannot do without anything. Without coordination we cannot do anything else. You may say for works, for physical works where we spend we spend huge materials, we spend resources like human resources like machines, fuel, and we do our budget controls there, but we do not value coordination in that work. And coordination engineering, or you may say engineering coordination, because it is technical as well as practical. Technical in the sense that we have to coordinate from design stage to working design stage to executive design stage. Design stage or pre-design stage. Design stage including pre-design stage. I say my statement, my contention says pre-design stage and design and working design stage are same. Then we have to consider about practically doing them on site, and that is through working drawings, through execution drawings we have to execute, and without drawing nothing works. That's why drawing is very important part of controls. Therefore whatever work we do, that work has to be conducted, that work has to be carried out meeting requirements of what some designer defines or specifier defines, and we call them specifications. The specifications also will play a very important role in activities of projects, and we have to understand specifications very well, and those specifications control project, because if we do not control them we cannot do project standard wise or whatever is expected. And this also can be classified in different way, and engineer can classify itself. Either engineer means designer, or specifier, both. So as I say, I'm sorry, as it is said on this text, designs, construction and controls are very absolutely interrelated requirements for achieving from successful commencement to successful completion of a project scope of work, which all must be applicable throughout project stages, with all works be smoothly affected. These sections or stages are initial conceptual designs. Of course, we can analyze this in this way, in sequence, that it is initial conceptual designs, designing for works execution purposes. Procedure implementations about how to chart out construction of designed project works. Project construction works, currency decision. Here currency means duration of project, how long it goes on, that is called currency, means current state of this project. Project is always current if it is not completed, so it's called project construction works currency, and not your hard currency. And decision we have to make about that project construction works currency decision, that's design and works carrying out, what works we carry out, what sort of testing we do, we have to define either in specifications or in standards or otherwise. Means where you think that this test is must be satisfied with this, only then we can say alright, compliance has been done. When project title terminates, and you know why I'm telling this, project is an entity, it's like a product, you start manufacturing and deliver that. And same way, project has got two dates, very important dates, and one is date of start. Date of start means date of start of that contract. Project means project which is contracted, and date of handover of that project or completion of that project. And without, both are called date of start of project and date of completion of project. And after that, it's not called project, it's called project delivered or contract performed. Contract has to be understood in clarity, that it's not means a contract exists there where, and for such major projects contract is practically a must. And if you have capacity to do yourself, you can do yourself. There's no way to stop you, but generally it's not done. Keeping abreast technical work, administrative work, liaison work, coordination work, this work and that work, it's not very easy to say that we shall do it ourselves. First of all, it is technical requirement, market requirement, material requirements, machine requirements, or so much practical requirement that we do not know how to conduct. So it's not possible. Even contractors do not know, but they take contracts. Well, that is different business. Means self-interests are involved sometimes, but when you say we consider fact, and fact is different, that might we have to be very clear about. And this is question of design, this is question of other items. Or you can say when you say project is over and construction work has gone, stage is over, and launching your project starts, and commissioning and launching we call it testing. When testing also we can say pre-testing, and also testing, and then we can say testing at various levels. During work itself, we say this is first fix testing, this is second fix testing, this is pre-completion testing or pre-final testing. And then we can say, okay, we can classify testing in a number of ways. It depends, means how best you can check, how best you can do your controls, and particularly in those items which may not be tested after this work is over. So during work itself, we have to check, we have to inspect, we have to do. All those are defined in procedures, and we call sometimes ITPs, or we call ITPs, and before that is checklist also, we call it checklist. So those checklists and those test plans are very important. We have to design them in line to what we plan, how we process it. And we can say that the statement, we give name to that statement, and that's called method statement or construction method statement, which gives outline and details both how shall work be done. And that's a very important point of quality engineering, because if you don't have some detailed method statement, then we don't know what is compliance requirement, what is contract requirement. It's not necessary that we keep this party for everything. We have to understand the scope of work, and that's why scope of work is defined in contract as well as on every method. What is scope of this method, what is scope of this method and that activity. And that point is also very important and significant, and we cannot just skip it. We cannot skip it. So sometimes what happens, some method does not have in its contract every part involved, so we have to define scope of work, and we have to refer to documents, we have to refer to which drawing it is, which specification it relates to, and what is in our scope that we give value. So we can say when title of project is finished, this means project has been delivered. You just think of this way. If title, if say now this is no more project, it has been inaugurated or it has been completed, then project responsibility is over. And if in that contract you have a maintenance period also, in that case project is over, but maintenance of project goes on and on and on until that period is also over. These points you have to understand, that what is project. Without dates you cannot call it projects. Yes, then you can call it annual operation. annual repair, annual maintenance, or not, you can say construction or project activities. Project, that's why it's always temporary. It's like one goes to school at age of 5 and it comes back at age of 16 or 17. That can be called date of start of your study and date of passing your examination. That way you can say this my school project, studies project, and we can say designs come into picture on projects. And designs means we devise something, luck you can say, of some material, how material shall be used. If material exists, we have to know about material in details. We have to know about workers' capacity, and we have to know about what support equipments are required. All this part of design. This is design means it's not we can stick to design in design terms. Design means so many sub activities are involved in designs. In that you can say structures are involved, finishes are involved, or materials are involved. Everything is involved. Shop drawings are involved, drawings are involved. But at that time we start something, maybe shop drawings are not available or not finalized, working drawings are not finalized, but contract has been finalized, and that is important part. Once it is finalized, then there is no solution for that project not to do, for that work not to do, because it is agreed by both responsible partners, responsible parties, that is owner and contractor. So it's therefore very important that designs may be considered safe and over safe or optimum. But real construction involves actual expenses, contract time, financial liabilities, etc. That point we have to be very clear about. And if we don't understand these factors, which are called in our standard triangle of organization of projects, I call it triangle of organizations of projects or projects organization, and that is first is cost, then it is time, and then it's you can say quality. Both are in triangle corners, and they perpetual means no one is higher than other one. All these three have to move together, otherwise if one drops, other two shall also drop or shall not be active. And that's point we have to be very serious about in this, that design may be considered safe, over safe, or optimum, but real construction involves actual expenses, contract time, financial liabilities, and building's professional reputation, which all must be cared of sincerely by both stakeholders as such, owner and engineer, or designer at that stage when work has not been awarded for construction, till it is in hands of designer or engineer and owner, because they have to work together. Engineer has to work for owner for purpose of devising documents of contract, and that is very busy work, very time consuming work on lump sum fixed price projects. It should be certain objective of an organization to apply good controls on project so as to keep in line on schedule of contract performance, planning being an actual part of contracts. Control includes progress. You must get progress also. I'm not saying don't worry about progress. Progress is first requirement, but quality is also first requirement. Don't forget that. Control includes progress, cost escalation also. It happens on generally long duration projects. Generally, it happens that escalations are recorded. Cost escalations due to whatever reason, due to price rise or due to, you can say, non-availability of material or whatever happens, or some unknown circumstances can cause this cost escalation. And of course, when cost escalation and time are linked, so there's a time also required here for that. And budget we have to understand. It's very important part for an engineer to understand budget. And if you don't understand budgets, keep our eyes closed. There is no meaning of professionalism here. Quality requirement or quality assurance, which you call it, generally I call it quality requirement assurance, because quality assurance doesn't give any meaning. What we say, requirement gives some meaning that it is mandatory. It's not optional. So we cannot simply use assurance, rather it's better if you use quality requirement. Quality requirement definition, you can call it coordination engineering as well as total engineering. It's very important part. I said total engineering, where quality engineering is important, but of course it goes with quantity. Quantity of what I say, it is total engineering, which is inclusive of quantity and quality and all other involved factors. And just like we say total system management or total quality management, you can call it, or total management system, you can call it, whatever you can call it, it's up to you. Total management system, this means quantity system, quality system, and all other requirements make total engineering. Its safety, its risk covering, its delays, recoveries, or whatever else is impactable. So that's why I say control includes progress, cost escalation, time, budget, quality requirement assurance, coordination engineering, as well as total engineering, and safety, risks covering, and delays, recoveries are very important fact points that we think should be controlled. These are all integrated divisions, not separate one, though in existence they are separate, but they are integrated virtually, practically, and if you can't integrate them, and this cannot be, shown in a legal way, everything must be clearly defined. It depends on, and site work is very different, particularly, and of course design work is different, but there are people sitting in designs who are well educated, well qualified, but on sites you may find very educated people, very rarely, because very educated people, excellent, extremely knowledgeable people, they don't want to sit on site. They don't want to expose their bodies in adverse weather conditions, but they try to sit in offices and claim that I work in office because I work with mind, as if others who don't work in office, they don't use mind. Well, that's definitely. So we can say these are all integrated divisions which should move in unison to achieve project deliveries, targets. There are so many divisions here. You can think yourself and you can know very well what I'm talking about. Division related to quality efficiency, quality promptness, and not just doing job for sake of doing, but I do job for sake of happiness, for sake of pleasure. And that's up to what is constitution of your body or mind, and what's your interest in that field you are working. If you're not interested in that field, I would suggest better don't go to that field. No use. So we also can start well-designed project, very excellent, very, great thoughts project has been done, devised and designed, and we can also say that a well-designed project could be jeopardized. Jeopardized, what's the meaning of that? During construction phase. Construction phase from budgetary viewpoint, should it not be given due required controls application properly? And that's the point I'm talking of. It's very important one. A well-designed project would be jeopardized during construction phase. From budgetary viewpoint, should it not be given due required controls application properly. Without organizing with full intensities, you can say, Keeping eagle eyes on project means we have to keep constant eyes, constant attention, responsible focus on that point which we think is problematic, because it's not one person who is working, who works on that project. It's so many hundreds workers work, many hundreds people, persons work, and we have to keep control on everyone. And it's not as easy. It's not a standard activity we do. We do activity which are to be controlled at each stage in a different way, and we can't expect that seriousness. Yes, people work, personal work with, they spend hard work, they spend smart work, but as far as focus of attention on quality issues is concerned, it's not. We can leave it to them. We cannot leave it to them, even though these personnel are expert, because they know how to do, but they cannot define it. So either we have to teach them, or we have to learn it, something that how to check them at random, because we cannot say this is a job description, do it. For them it's no meaning. Yes, they will do job and they know it's my job. So you can start. We have to be very clear about that. Explanation or training them is our responsibility, because if they have had training, then why should it come to you in a way to serve? So that's a very important point. Without organizing with full intensities and keeping eagle eyes on project and construction controls, no project can be delivered in time and in fixed budget. And we have to face losses on that account every day. Some loss, and some loss, and that sum plus one becomes absolute sum. Whereas then, without organizing with full math intensities, with full eagle eyes, we cannot do anything, and that's what we can say. Our budget is disturbed, our time is wasted, you may say. Budget is disturbed, time is wasted, and we should understand that when time goes away, it cannot come back. And when money goes away, it also cannot come back. At that point, we have to think seriously. And particularly youth have to realize that it's not on its own that happens. We have to work on this. We have to work for this. Word cannot be developed just sitting in offices. We have to go to development places, and that's the only when we can say we can do it. And for educated people, young, it's easy to go to that level and find more and more answers. It's not study of books in your whole year and you pass examination. It is production, it is creation, and creation is always very risky because it gives you losses also. So we can say, without organizing with full intensities, keeping eagle eyes on project and construction controls, no project can be delivered in time and fixed budget. And that's our coordination file. There are so many more issues in this. We will come back. Now we go to, just for a change, we go to the specifications, and that's too very important. And we call it, it's concrete specification document, and that relates to some standards adopted somewhere, and this is for Qatar specifications, Qatar concrete specifications. We've covered many pages of this, many topics in this, many sections of this. Somewhere on fine aggregates, now it's coarse aggregate. Of course, plus right, but refresh it before going further. That refresher is very important, of course. In engineering, everything is very important. We cannot leave, okay, this is not important, leave it, we'll see it later on. That's not a way. We have to be serious about that, very, very serious about that. I'm just keeping watch on battery also at the same time. So I say coarse aggregator, maybe people are not clear actually. It's not something, you know what we are talking about. It's stone, small pieces of stone, and we call them coarse aggregates. Coarse aggregate is a kind of granular material. Grains, where size may be different, but it's like grain, it can interlock together. Each pieces, they can come into contact with other one through interactions, interrelations, and there are many kinds of definitions. Soil engineering, but we have to now discuss about interactions or quality based on that. Coarse aggregate is a granular material. It may be natural or it may not be natural. It may be manufactured one. It may be recycled one, or by combination of mismanufacturing or recycling or natural. All be free from deleterious matters. That it should not have any deleterious matter that cause damage. It cause problems in this means from deleterious matter and conforming to requirements of physical and chemical properties that we have to meet. If you bring some material into object or the definition of that, it meets this requirement. If that requirement applies onto this, and if in the case that's applied and we don't have, then first we have to provide that information, and we can just insert in that information on this specification, we can say. So these physical and chemical properties requirements, and these are subject to, of course, formal acceptance by authority, and that authority is the engineer, and that acceptance is a must, and then it's on record. It should be. And we can say we can import aggregate also. For imported aggregate, we may say these standards may be published. More requirements of standard also is no. Now, for other types of concrete mixes, sorry, and subject to engineer's acceptance. Engineer, again I say, it is engineer of contract, not ordinary engineer. It's a decision-making body, technically and professionally also. So for all of the types of aggregate, all types of concrete mixes, and subject to engineer's acceptance, coarse aggregate comply with relevant codes. Nominal mixes size of coarse aggregate not larger than 1/5 narrowest dimension between sides of forms. We have to relate aggregate size, coarse aggregate size, to dimension of section. It's very important one. It can be whatever section, but it says that 1/5 of narrowest dimension, says nominal maximum size of coarse aggregate should not be larger than 1/5 of narrowest dimension between sides of forms. Let us say it is 20 centimeter or 200 mm, and it says 200 mm 1/5 is how much? 40 mm. So it says that 1/5. If it is, dimension I said is 150% of this, it should be minimum. 20% means 1/5. Okay, then we can say, if it's say some dimension is 50 centimeter, for example, so 1/5 is how much? You can see 50 mm dimension. Let us suppose the 1/5 is very small, and people may not realize this fact. Or it can be 1/3 depth of slab. You also know this. If slab is 150 mm thick, then it should be 1/3, not more than 1/3. And that may be whatever. If it is, if say, we'd never use more than 20 mm aggregate in designs. It's very rare in some quantity of 40 mm size, nominal size onto concrete. So 1/3 depth of slab, 3/4 minimum clear spacing between individual reinforcing bars or wires, bundle of bars, or you can say individual tendons, bundle tendons or ducts. It's just normal. These limitations do not apply in judgment of licensed design professional. These limitations shall not apply if in judgment of licensed design professionals, workability and methods of consideration workability and method of consolidation are such that concrete can be placed without honeycombs or voids. It's very important that we have to understand voids and you can also say honeycomb, which are working defects in concrete, not theoretical defects. This happens because of lack of supervision, lack of concentration, and we leave it to those we think they are very good for us. And people should be good for us. We should understand that people have to take responsibility also. And, we can start requested by contract related engineer, contract shall mechanically and you can mechanically wash aggregate to remove all salts and other impurities in order to meet requirement specified. Then we come to this is only small discussion on aggregate was coarse aggregate, and you know what coarse aggregate is. You can see small stone pieces which are used in concrete mixing. This is higher than fine aggregate, which is sand or sand. So in life, sand this what do you say? This material of fine aggregate, these are both important for concrete. It's a very important part, and we can combine them in a way that combination is very important. That we understand. What's that? Metal passing 0.063 mm. 0.063 mm. You think yourself, just 1 mm. And you use the formula here that whatever result is, whatever it is, that has to be divided by original, and you get this factor we are getting. So it is that factor. We have to realize this point, how to get it. Combined aggregate for concrete is very important because combined means both aggregate, fine and coarse. Metal passing through 0.063 mm sieve shall not exceed 3%. That is first way. Means more metal passing through 0.063 mm, which cannot be even seen, cannot be felt. It should not exceed 3% of combined aggregate. It should not exceed 3% of combined aggregate, and that's the important part. Metal passing 0.063 mm. One, we know it's one more than one, less than 1/16, 1/16. What we say 1 mm. 1 mm less than that it is 0.063. Not even 0.6 mm. 1/10 of 0.6 mm. You can assume single of one and multiple of others. You can define anyway. Metal passing 0.063 mm. Sieve shall not exceed 3% of combined aggregate. And it's really wonderful to say. It's very wonderful here that you can say metal passing 0.063 sieve shall not exceed 3% of combined aggregate. But how to know that percent is a question of procedure, testing, and also remembering that we have to test it first. Combined aggregate gradation used in work shall be as specified, except when artificially it's gone. What do you say then? Combined aggregate gradation used in work shall be as specified except when otherwise approved or directed by engineer. Changes in approved gradation. Changes in approved gradation shall not be made during progress of works unless approved or directed by engineer. We have to fix to defined criteria unless it is further approved. And that point is of course important. Then we can say washing and processing. I am trying to give you information about concrete, which is very much recognized and required, but it doesn't give anything. So that is what I say. Also we say where aggregates have been washed shortly before delivering to site. It happens that you can say washed aggregates have been washed shortly before being delivered to site, or stockpiles have been sprayed to cool them. What happens? Samples of aggregate below. So what is saying? Again I say where aggregates have been washed shortly before supply or delivery site, or if stockpiles have been sprayed to cool them, samples of aggregates shall be taken frequently to determine correct amount of water to add to mix. A lightweight aggregate. Lightweight. We know meaning of lightweight. Everybody knows meaning of lightweight. Lightweight aggregate are those having particle dimensions not exceeding 2 tons per meter cube or 2000 kg per meter cube, or loose bulk density. Loose bulk densities says, or loose bulk densities not exceeding 1200 kg per meter cube. So its lightweight aggregate are those having particle densities not exceeding 2 tons per cubic meter, or not exceeding, you may say, loose bulk densities. That was heavy particle density, but I am talking loose. When it's loose, and bulk density we check should not exceed 1200 kg per meter cube. Well, this is density in standard one. It varies from one place to another place depending on what we do have. Lightweight aggregate include natural aggregate. Natural aggregate lightweight aggregate shall be in accordance with BSEN 130551, BSPI PD 66824 or equivalent ASTM standards. So we can say lightweight aggregate include natural aggregate which are manufactured and from manufactured local material. We can say natural materials, manufacture of natural materials, and are of or by product of industrial processes. Some recycled aggregate. I have to keep this in mind. Lightweight aggregates include lightweight aggregates include natural aggregate, you can say 5 o'clock. Lightweight aggregates include natural aggregate manufactured from natural materials and or byproduct of industrial process, and some recycled aggregate. Also, we can say recycled aggregate. Lightweight aggregates shall be in accordance with BSN 130551 and BSPD, that is published document, published standards, PD, published document 66824 or equivalent ASTM standard. American Society of Testing Material Standards, can say. We come to coarse recycled aggregate. This was only lightweight aggregate. Before that, washing and processing, the lightweight aggregate. Now recycled aggregate. It's now talking about what does it mean. Coarse recycled aggregates. Of course, we know this. How does it work? Excavation waste, we can call it excavation waste. Waste, you excavate, you get some waste. Then coarse recycled aggregate, we call it RA, recycled aggregate. Excavation waste is EW, spelling is excavation waste. And coarse recycled aggregate is RA. And coarse recycled concrete aggregate is RCA. Coarse recycled concrete aggregate is RCA. And recycled aggregate is RA, is coarse. Shall meet with requirement of table 2. What is that we see now? With exception that water absorption shall not exceed, which you have to keep in focus, otherwise you fail. What shall be attention? This table will discuss with exception that water absorption shall not exceed 3% for structural concrete and 4% for non-structural concrete. That is a point of importance here. Water absorption shall not exceed 3% for structural concrete and 4% for non-structural concrete. For structural concrete, you may say excavation waste or coarse recycled concrete aggregate, you can say, may be used in designated concrete. And for structural concrete, EW and RCA. EW is excavation waste and RCA is recycled concrete aggregate. May be used in designated concrete of maximum C30. C30 just indicates strength. Its proportion shall be not more than. Its proportion shall be not more than. For structural concrete, we have said that for structural concrete, EW and RCA may be used. Recycle concrete aggregate, coarse aggregate, may be used in designated concrete of maximum C30. Maximum C30, not more than that. You have to keep that in mind. For structural concrete, EW and RC may be used in designated concrete of maximum C30. Its proportion should not be more than a mass fraction of 20%. Its proportion shall not be more than a mass fraction of 20% of coarse aggregate. That is BS 850002, except where approved by Qatar standards. Use a higher proportion. Now we say, come back to this point here, 20% is a saying not more than 20% of course aggregate, except where approved by standards. For non-structural concrete, this for structural concrete we say, and non-structural concrete can be given some concession, and we can say what's that. For non-structural concrete, such as crash barriers, that's non-structural but protective one, and soakways, EW and RCA, may be used in designated concrete of maximum C40. C40, it was C30, it's C40, right? It was C30, is it? Just check it. Yes, it is C30 in that case of structural concrete. In case of non-structural concrete, it is C40 concrete, not more than that for such aggregates, that is excavation waste or coarse material fractural aggregate. Its proportion shall be not more than a mass fraction of 50% of coarse aggregate, also in BS 8502, except where approval is obtained from Qatar standards. In that country it is. So we have to see how RW, EW and RCA can be used instead of C30 and C40. For non-structural concrete, RA may be used in designated concrete of maximum C25. Its proportion shall be not more than non-structural concrete, RA may be used in designated concrete of maximum C25. Its proportion shall be not more than a mass fraction of 20% of coarse aggregate, except where approved by Qatar standards. All right. Or you may say your country standard now. When composition of coarse RCA, recycled concrete aggregate, and coarse RCA is tested in accordance with provision of scored test result obtained for each type of particle shall not exceed maximum value specified in table 2.2, and that is when composition of coarse RCA and coarse RA is tested in accordance with BSEN test result obtained for each type of particle shall not exceed maximum value specified in table 2.2 will be that. EW aggregate shall meet same requirement of RCA as indicated therein. This is table 2.2, requirement for coarse RCA and coarse RA mass fraction percentage. This is what I'll just keep it a little up requirement. It says type of aggregate, maximum masonry content, maximum fines, maximum lightweight material, maximum asphalt, maximum foreign material, namely glass, plastic, metals, maximum acid solution. Always we have to find it, how to do it. Today is a little bit hot. Temperature is fluctuating a lot. That is the problem. Temperature is fluctuating. It's 21 morning time. See now it is how much I can tell you. Just a minute for record purpose. What is happening? We have to see that also. What is current status? I'll just tell you what is that. It's 21 degrees Celsius at 5 a.m. 5:10 a.m. 21 degrees Celsius in Faridabad. And wind gust is 18 kilometer and wind is 10 kilometers. Humidity is 80%. Indoor humidity is 80%. That's how I'm feeling. And dew point is 17. Cloud cover is 31%. Visibility is 16 kilometers. Cloud ceiling is 12.2 kilometers. And daytime is expected 36 degrees Celsius. Maximum UV expected 7. Wind that time maybe 15 kilometers per hour and wind gust 35 kilometers. This is production, and night maybe 10-19 degrees. So that's why anyway whatsoever it doesn't matter. But now when we are talking of concrete, it's very important that we have to refer also to some such concrete specification, they can say. Cement concrete specification, the 1 to 4 etc. I'm not interested in that. I just want to some standard one. I'm not interested in CPW government and now SlideShare, no concrete doc, or what concrete doc says specification of concrete. Let's see that one, concrete.org. Let's say we should know what people say about this when we are discussing some specifications. Really we have to be with world, and world should know. It's not just American Concrete Institute this is, and specifications for concrete, and says that ACI concrete terminology, definition, an explicit set of requirements specified by material, product, system or service. ACI concrete terminology. ACI defines an ACI reference specification as standardized mandatory language document prescribing materials, dimensions and workmanship, incorporated by reference in contact documents, with information in mandatory requirements, checklists required to be provided in project specification. A reference specification provides most detailed construction requirements that architect or engineer must convey to contractors. Long list is there that I'm not going to open, but I just want to say what standard and documents and then journal articles, all this is here. That's not. So this is only brief we got from here that ACI defines this as concrete, not more than that. And terminology, I think we have discussed already concrete terminology long back, you remember that. I'm not going to do that again, it's just waste of time. And the other one is this was concrete.org, and this is test of standard specification concrete and standard specification of concrete. This is material construction, Japan Society of Civil Engineers. Let me see what it says. Japan Society of Civil Engineers says something in PDF format, and what it is better if it's PDF. I can show to you also that time. And Japan Society of that is here now. I think it's PDF, so you should see this, right? You can see this. Guidance for concrete, 530 pages. This is good. Standard specifications for concrete structures, 2007, materials and construction, and Japan Society of Civil Engineers. And this is this interesting one, is it? We should go through this. Or maybe some depends on what sort of information is. Standard specifications for concrete structures and structure we have here. And let's see that materials for construction, published by, this was published in 2010. Okay, then we have to see. Well, let's see what preface says at least in first paragraph. I think you're viewing this, right? I think you're viewing this. It's available to you, and I think you're viewing this. Is good if you're interested in that. It's very, very good that so we are having Qatar here in Japan airport. Concrete structures have supported our society. Let me save it also first, because it's better to save. That is important one, and this concrete. Let me say concrete right here. Concrete. So let's say it's saved. Now, concrete structures have supported our society, it says, as infrastructures. Society can only preserve itself in wholesome, with tough, beautiful and durable concrete structures. Concrete Committee of Japan Society of Civil Engineers, leading organization for investigation, research, technological promotion and education of concrete in Japan, considers issuance and revision of standard specifications for concrete structures as its most important activity. Standard specifications for concrete structures, which shows model for plan, design, execution, maintenance and repair of concrete structures, have been highly recognized in practice and contributed to development of concrete technology in Japan since its first publication as standard specification for reinforced is called 1931. So it's very old, 1931 started with. In order to cope with development of concrete technology in Japan and worldwide trend, Concrete Committee converted all specifications in JSCE, namely structural performance verification, that is structural performance verification, seismic performance verification, material and construction, maintenance, dam, concrete and pavement, from prescriptive code to performance-based code. Prescriptive code to performance-based codes, and completed work in 2002. This revised edition adopts technological development after 2002 and intends to enhance performance-based nature in standard specifications. This revised edition adopts technological development after 2002 and intends to enhance performance-based nature in standard specifications. For practical efficiency, 3 specifications: design, materials and construction. And dam concrete, one is, that is, for practical efficiency, 3 specifications: designs, materials and construction. These are 3. Dam concrete present not only general provisions for verification of specified performance requirements, but also standard methods as simplified methods to achieve performance requirements under certain conditions. JSC are ready for practical use as it describes role of each specification during plan, design, execution, maintenance and repair phases, as well as relationship among them. And for first time, it also describes role of engineers for construction works. JC, JSC, SSCS is yet an ultimate one. There are still remaining tasks such as inclusion of provisions for scenario of concrete structures during service life. What readers can find in this revised edition is rationality. Rationality with performance based concept and applicability for practice, showing high level of technology in Japan. This revision consists of 5 specifications. One is design, design which combines previous structural performance verification. Design which combines previous structural performance verification and seismic performance verification. This design combines previous structural performance verification and seismic performance verification. Together, materials and construction, maintenance, dam concrete and test methods and specifications. The specification of test methods and specifications was used separately in May 2007. The specification of payment was published as standard specification for payments 2007 by Committee on Pavement Engineering of Japan Society of Civil Engineers, which has taken over issuance and revision works from JSC. Finally, this is from Toyoko Miyagawa, Chairman, Concrete Committee of Japan Society of Civil Engineers. Finally, I will like to show my most sincere gratitudes to whoever are these. All right, this is gratitude, so I leave it. Now, it says preface to English version. All right, so leave it also. Then we go to committee with standard specifications. All right, these are authors involved in this, so all thanks to them. But I am using their document. Standard specification for concrete structures 2007, materials and construction. Contents, application of standard specifications of concrete structures, general requirement. Let's see contents. And we cannot go all pages, too long it is, 530 pages. Chapters, general provisions, that general definitions, then construction plan, what's that? General considerations of construction planning, determination of concreting method, determination of construction performance of concreting, materials, concrete mix design, verification of concrete performance, confirmation and alteration of construction plan. Construction is general, then quality control, general and inspection, general inspection plan, conduct of inspection, maintenance of inspection records, construction records is general, and then we construction standards, that is general definitions, and quality control, that says, and these contents are general. Then let me see my file, it may not go down. Oh, 23%, I should be very strict here. I was just in 23% it is, so I should be serious about this. There's problem, sometimes they forget and they switch it off, then there's problem. Actually, it would be a problem otherwise. This video might have disappeared, That's why it's hot also, and 22% available plug-in charging, so it's okay. It's plug-in charging now. Now let us say Let's see how does it work. Now I put off this also. Well, now it says now that it is general qualitative consistency, workability, that is filling ability, pumpability, setting properties, and then filling ability, pumpability, and setting properties, strength, durability, general and durability. It is general. It is durability of concrete. Workability, filling, pumpability, setting properties, then strength and durability, general, then durability of concrete, and steel protection performance, water tightness, and cracking resistance. Constituent materials says general, cement, mixing water, aggregate, that's fine and coarse, admixture, the general, mineral admixture, chemical admixture, reinforcing materials, reinforcing bars, pre-stressing steel, structural steel, other reinforcing steels, storage of materials, storage of cement, aggregate, admixture, chemical admixture, steel, and mixed design, general procedures, max design, target performance of concrete, defining target performance, workability of concrete, specified strength, durability, determination of mix requirements, determination of mix requirement, and we have here maximum size of coarse aggregate, and slump is required strength, then water cement ratio, air content in air entrained concrete, determination of provisional mix proportion, right? Determination of provisional mix proportion, and this is water content, cement content, powdery material content, sand aggregate ratio, unit quantities of admixtures, trial mixing, general and trial mixing method, representation of mix proportions, concrete production, general production plant, we call pitching plant, so production plant doesn't matter, storage facilities, measuring equipment, mixers, measurement of materials, mixing, plasticization of concrete, ready mix concrete, general selection of plants, specification of qualities, receiving, transportation, placement, compaction, and finishing, general time for mixing to finishing, placement, transportation, transportation to construction site, on-site transportation, concrete pump, buckets, chutes, other transportation equipment, placement, preparation, placement, compaction, then finishing, surface finish of placed concrete, correction of surface finish defects, spatial finishing, curing, general, moist curing, temperature control curing, protection against harmful effects, joints, general construction joints, horizontal construction joint, vertical construction joints in columns and walls integrated with floor system, construction joints in floor system, construction joints in arches, expansion joints, joints to control cracking, reinforcement, general, fabrication of reinforcement, assembly of reinforcement, bars, joints of reinforcement bars, placement of pre-assembled reinforcing bars, formwork and shoring, general, load, general, vertical loads, horizontal loads, lateral pressure of concrete, spatial loads, material, design of formwork, design of shoring, preparation of formwork, preparation of shoring, removal of formwork and shoring, spatial formwork and shoring in that general slip form movable shores. Cold weather concreting. I think I'll get better information from this probably. General materials, mixed proportions, mixing, transportation and placing, curing. And formwork and shoring, hot work concreting, general materials, mixed proportions, mixing, transportation, placing, curing. Mason mass concrete, general material, mixed proportion, production, construction, partitioning into blocks, lift height and joints, placing, curing, formwork, crack inducing joints. Quality control, and that is general quality control of concrete material and reinforcing material, quality control in concrete production, quality control of concrete, quality control during construction, quality control of concrete structures, inspection conducted by contractor, general, construction records, inspection standards, general, general definitions of terms, inspection plan, inspection for acceptance of constituent materials of concrete, general, cement, mixing water, aggregate, admixtures, inspection of concrete production facilities, inspection for acceptance of ready-mix concrete, acceptance, inspection for reinforcement, inspections of construction, general inspections of concreting, inspections of reinforcement, inspections of fabrication and assembly of reinforcing bars, inspection of joint of reinforcing bars, inspection of formwork and shoring, inspection of concrete structures, general, inspection of surface texture, inspection of locations and dimensions of concrete members, inspections of concrete properties in structure, inspections of cover, loading test of member and structure, records, general identifiers of structure, spatial concrete, scope and definition, expensive concrete, in that is general scope, general quality of expensive concrete, general expensivity, strength, materials, cement, expensive admixture, mixed proportion, general quantity of expensive admixture per unit volume of concrete, quantity of cement per unit volume of concrete, presentation of mixed proportion, production and construction, mixing, curing, inspection. Now inspections, expensive admixture acceptance test, concrete acceptance test, lightweight aggregate concrete, general scope, general quality of lightweight aggregate, quality of lightweight aggregate concrete, mixed proportions, general mass of unit volume, water cement ratio, in-slump air content, then presentation of mixed proportion, production construction, selection of plant, transportation and storage of lightweight aggregate, control of moisture content of lightweight aggregate mixing and transportation within construction site, placing and compaction, surface finishing, and inspection for acceptance of lightweight aggregate, inspections for acceptance of lightweight aggregate concrete, concrete using continuous fiber reinforcing materials, CRFM, fiber reinforcing materials. In general scope, general in materials, continuous fiber reinforcing material, reinforcing steel bars, anchorages, and couplers on protection materials. In construction, handling and storage of materials, shaping, assembly, and placing in position of continuous fiber reinforcing material tendons, CFRM reinforcement, etc. Shaping and assembly of CFRM materials, that is continuous fiber reinforcing materials. Shaping and assembly of CFRM, continuous fiber reinforcing material. Making ducts other than sheaths, placing sheaths and CFRM tendons. Placement of concrete, pre-stressing. Inspections for acceptance of materials, inspections for protection of CFRM shaping, CFRM as we said before, that is shaping of CFRM, supply, assembly and placing of CFRM, continuous fiber reinforcement material, making ducts other than sheaths, placing sheaths and CFRM tendons, placement of concrete pre-stressing, inspections for acceptance of material, inspections for protection of CFRM, short fiber reinforced concrete. General scope, general quality of short fiber reinforced concrete. General is scope, general, and quality of short fiber reinforced concrete. General strength properties, compressive strength, tensile strength, flexural strength. Deformation characteristics, deformation characteristics and under compression, tension softening properties, flexural toughness, prevention of explosives, prevention of spalling, other performance, short fibers, steel fibers, synthetic fibers, then mixed proportions, production, placement, application. Alright, I lost my track due to some imagination. So deformation characteristics, deformation characteristics under compression, tension softening properties, flexural toughness, and prevention of explosion, prevention of spalling, other performance, short fibers, steel fibers, synthetic fibers, mixed proportion, production, placement, application, fiber addition and mixing, transportation, inspections for acceptance of short fibers, inspections for acceptance of concrete delivery. We have somewhere in there 300 pages now. High strength concrete, and general is scope, general quality of high strength concrete, materials, cement and admixture, aggregate, chemical admixture, mixed proportion, strength, slump or slump flow, air content, water binder ratio. Water content, unit content of coarse aggregate, production, selection of plants, mixing, production control, in construction, transportation within construction site, placement and compaction, finishing and curing, formwork, inspection, High fluidity concrete. High fluidity concrete, not viscous one. This is general scope, general. Quality of high fluidity concrete, general self-compactability, materials, mixed proportion, selection of types of high fluidity concrete, mixed design, representation of mixed proportion, production, selection of plants, storage of aggregates, mixing, quality control during production, construction, transportation and placing, finishing and curing, construction joints, formwork and inspection. Concrete shotcrete, now this was high fluid concrete and before it was high strength concrete. So these are that high strength, high fluidity concrete. Now shotcrete. Shotcrete, that is general, is scope and general. And of course quality of concrete, general mechanical properties of concrete, materials, cement, aggregate, self-accelerator, admixture and short fibers, mixed proportions, production, general production facilities, shotcrete machine and accessory equipment. In construction, general preliminary treatment of shotcrete concrete, shotcreting work, dust control measures, concrete protection, inspections, acceptance test for concrete material, concrete acceptance test, inspections of concrete work, pre-placed aggregate of concrete. General is scope, general, quality of pre-placed aggregate concrete, quality of concrete, quality of grouting material, mortar, mixed design, materials, mixed proportion of grouting mortar, representation of mixed proportion, production and placing, production and placing of ground mortar, production plant, mixing, construction and control, shuttering, charging, coarse aggregate, grouting equipment and injection pipes, pumping, grouting, construction joints, construction in cold weather, construction in hot weather, inspection, material acceptance test of pre-placed aggregate concrete and mortar for grouting. Underwater concrete, general scope, general underwater, ordinary underwater concrete, mixed proportion, placement, general, placement using trammy pipes, placement by pumping, placement using bottom discharge buckets or bags, anti-washout underwater concrete, anti-washout. Materials, mixed proportions, mixing, placement, protection of concrete surface. Underwater concrete used for cast in place piles or diaphragm walls. Underwater concrete pipes, ground concrete used for cast in place piles or diaphragm walls. Mixed proportions, pre-assembled, reinforcement, placement and inspections. Concrete for marine structures, general scope, general materials, mixed proportions, construction, concrete surface protection, installation of precast concrete members, inspections. Pre-stressed concrete, that is general scope, general quality of concrete, required compressive strength of concrete at time of pre-stressing, required workability of concrete, required performance of grout, general requirements, consistency, bond strength between concrete and tendons, corrosion resistance of steel, material pre-stressing, steel, anchorages, couplers and aviators, streets, grout for pre-stressed concrete, auxiliary materials for injecting grout for pre-stressed concrete, protection or protecting duct, coating materials for unbonded tendons, materials for jointing precast concrete members, storage of materials, proportioning of grout mix, execution in that installation of tendons, cutting, bending and placing of pre-stressing steel, installation of sheaths, protecting tubes and tendons, formation of ducts, assembly and installation of anchorages, couplers and deviating devices, assembly, arrangement of openings for grouting, exhaust and discharging, formwork and shoring, casting and compaction of concrete, pre-stressing general requirements, calibration of tensioning required equipments, control of pre-stressing, protection of anchorages and end surfaces of members, then it's grouting, general requirements, mixing and agitating, grouting, treatment of injection inlet, openings for air vent and grout discharge, grouting in cold weather, grouting in hot weather, manufacture and construction of precast members, manufacture, transportation, storage, jointing, erection, construction of external cable structures, handling of tendons, assembly and arrangement of anchorage, john, assembly and installation of deviating devices, handling of protective tube, control of pre-stressing, injection of anti-corrosives, inspections, material acceptance test, pre-stressing steel, anchorage and coupler, sheaths, adhesive agents for inspection, material acceptance test, pre-stressing steel, anchorage and coupler, sheaths, adhesive agents for joining, jointing precast members, inspection of grout, acceptance test of grout, inspection of grouting, inspection of execution, inspection of sheath, protecting tubes and tendon arrangements, inspection of anchorage and coupler, assembly and arrangement, inspection of opening layout for grouting, exhaust and discharging. Steel, concrete, composition, structures. General, scope is general, materials is steel, concrete, production of steel members, processing of steel, factory welding, temporary assembly, assembly and transportation, erection of steel members, erection, temporary placement, assembly of steel members, jointing using high strength bolts, welding in construction site, concrete construction, inspection, general inspection for acceptance, inspection of acceptance of steel, inspection of acceptance jointing materials, inspection for acceptance of concrete, inspection for production of steel members, inspection of welding, inspection for tightening of high strength bolt, inspection for tightening of high strength bolts and inspection for filling conditions of concrete. Factory products. General, scope general, concrete quality general, strength of factory products, materials cement, fine and coarse aggregate, admixture reinforcing steel, mixed proportions general, workability, production, factory production, assembly of reinforcement, formwork, molding, curing, demolding and pressure pre-stressing, transportation and storage, erection and jointing, inspections, material acceptance test for factory products. And then we have application of standard specific concrete structures. I'll be back in a few minutes. And maybe I'll blow it down. You can read it. It's 100, maybe less, and you can read and come back. Just a few minutes, please. I'll be back as routine. all I forget what I'll do, and meanwhile also I put this back here. Application of standard specifications for concrete structures we're talking of here, and that is application of standard specification for concrete structures. What we're talking of here is important point, and also we have to see only 2 hours over no problem. I will see editorial notes for English version. The standard specifications for concrete structures are a model code of which is supposed to be applied in Japan with no legal bindings. Therefore, some contents such as Chapter 2 and 3 applications of standard specifications for concrete structures may not fit to practical schemes in construction industry in other countries. However, it's a hope that standard specifications for concrete structures could be a model code for other countries after necessary modifications of contents considering local conditions. Basic concept concerning organization of standard specifications for concrete structures. Standard specifications for concrete structures are regularly revised, reflecting state-of-art concrete technologies developed in Japan and other countries, and provides standards concerning technical aspects of concrete structures in a series of phases from planning to design, construction, and maintenance. In this revised edition, standard specifications for concrete structure design. Standard specifications for concrete structures design is composed of standard specifications for concrete structures, structural performance verifications, and standard specifications for concrete structures, seismic performance verification to enhance convenience of design practice, durability check, and initial cracking check, which should be discussed in standard specifications for concrete structures. Designs have been transferred from standard specifications of concrete structures, materials, and construction to standard specifications for concrete structures design. Preparation and revision of standard specifications for concrete structures pavement has been handed over to Committee of Pavement Engineering JSCE. Results are now published. Alright, we go further, and then general requirements for design materials and construction and dam concrete are described based on concept of performance-based code. Performance requirements are specified for structures, and methods for checking compliance with requirements are shown in general requirements. Alright, then we go to concrete structure. Let's go to so flow of work, how it is. Construction records are specified status. What is this? Planning, data, design, construction materials. Alright, so that's let's go to real contents of this. Yes, here we see we can better read it. I think it's better for everybody. Flow of work, what it says: construction records that are specified as standard specifications for concrete structures, materials, and construction provide important data for assessment. Construction records have specified standard specifications for concrete structures, materials, and construction, providing important data for assessments, deterioration prediction, and implementation of remedial measures in maintenance phase. Accurate construction records should therefore be handed over to maintenance engineers. Construction plans and various inspection reports should also be provided to engineers as required. Here it says performance. If I just select it for your convenience, it's that. Performance requirements for durability, safety, serviceability, and restorability. Performance requirements for durability, safety, serviceability, and restorability, which we can say reliability, that are specified in standard specifications for concrete structures design are determined in design phase. Construction and maintenance methods are roughly determined in phase. Data that affects construction and maintenance should therefore be handed over to next phase without fail in form of design drawings. This is just background. Now it's planning, design, construction and maintenance. This data is flow of work. Now it says figure shows flow of work from planning of a concrete structure to service commencement. Data collected in maintenance phase are not transferred to engineering works in planning, design or construction phase. It should however be taken into consideration that reflecting data in maintenance phase in planning, design and construction of another structure for improvement is important to extend service life of structure. Interrelationship is basically same for design, construction and maintenance, described in standard specifications for concrete structures, dime concrete. Each component of standard specifications for concrete structures described below. Standard specifications for concrete structures designs show standard methods for performance verification of concrete structures such as reinforced concrete, pre-stressed concrete and steel concrete composition. Let me see this file better. If you open this file, it will be helpful to us. But that's a Word file and I'm going to get this file here in this. And I'll close this file now so that we can be clear about what we are doing, and we'll move on to this again for your, because that is a word that on net and I don't want to keep load on net. So I just change that and copy here now. We'll go back if required. Again, it's not a big deal. I'll just move it down and come to same one. And let's see, page 79 is gone by error, no problem. Let's move it down. We go back to page 11, 12 or 12. Yeah, it's here, I think. It's here. This also will come back here. It's okay. So we are back here. This figure shows a flow of work. This figure shows a flow of work from planning of a concrete structure. It should however be taken into consideration reflecting data and maintenance. Okay, that we have done it already. Now each component of standard specification for concrete structure is below. Standard specification concrete structure, the design shows standard methods for performance verification of concrete structures, such as reinforced concrete. That is, performance verification of concrete structures, such as reinforced concrete, pre-stressed concrete, and steel concrete composite structures, and stipulates preconditions for checking and structural details. Revised standard specifications for concrete structures are not applicable to unreinforced concrete structures. Material, design values or other applicable items may however be applied to unreinforced unreinforced concrete structures, right? So they say standard specification for concrete structure design shows standard methods of performance for okay. Standard specifications for concrete structures, materials and construction provides basic general rules concerning construction of concrete structures. In construction phase, construction method and performance during construction work are determined based on design drawings and restrictions on construction. Materials are selected and concrete mix proportions are determined. A reconcreting plan is developed so as to meet requirements for water content, cement amount, cement type parameters. Whether concreting plan meets construction requirements or performance requirements of structure or does not is verified by an appropriate method. If requirements are not satisfied, concreting method is re-specified or mixed proportions are modified as long as conditions handed over from design phase are met. Standard specifications for concrete structures maintenance provides general basic principle concerning maintenance of concrete structures. In maintenance phase, documents such as design drawings and maintenance plans handed over from design phase and construction plans, as-built drawings, construction records and inspection reports handed over from construction phase should be fully used for efficient and effective maintenance work. In cases where use of functions of structure changes due to social changes, performance verification should be made. Performance verification should be made to verify whether or not structure meets resultant performance requirements or not. If designated performance requirements are not ensured, repair, strengthening or other remedial measures should be considered. Standard specifications for concrete structures, dam concrete stipulates performance and quality requirements for dam concrete and describes methods for verifying compliance with requirements and basic designs and construction principles. Descriptions concerning designs, construction and maintenance in standard specifications of concrete structures, dam concrete are different from contents of standard specifications, design, materials and construction and maintenance with many respects because of factors unique to dam concrete such as unreinforced nature and low or zero slump of dam concrete. Standard specifications for concrete structures, dam concrete therefore describes matters concerning design, construction and maintenance of dam concrete. Standard specifications for concrete structures, test methods and specifications list Japan industrial standards, provisions of JSC and other standards for methods mentioned in other four components of standard specifications, which work steps in respective phases described in standard specifications for concrete structure, design, materials and construction maintenance. Roles and deployment of responsible engineers. To produce and maintain a reliable structure, always I say reliable structure that meets performance requirements. Engineers involved should have a capacity to carry out work and high level of ethics. Very important for engineers. Engineers involved should have a capacity to carry out work and high level of ethics. In planning, design, construction and maintenance of concrete structures, engineers should make appropriate decisions under varying work conditions. Therefore, engineers with required technical skills should be deployed according to level of difficulty of work. In planning, design, construction and maintenance, therefore, responsible engineers not only with required technical expertise but also with responsibility and authority should be deployed in organizations of owner, consultant and contractor. It's very important part we have to think of. Now here is you can say flow chart, that is figure 2, work steps described in specifications for design. And you can say use and function of structure, plan for structure, specification for design, specification of performance requirements, structural planning, design plans, structural format, materials used, dimensions of major elements, construction methods, design of structure, specifications for design, specification of structural details, cross section, materials for arrangement, performance verification for structure. If it's okay, design drawing and other materials, structure materials, construction methods, maintenance plan, construction of structure. This is described in specific designs. Then planning of structure, design of structure, construction of structure, specification of materials and construction planning, verification and approval, construction, quality control, inspection, okay, as-built drawing and construction costs, maintenance of structure. This figure 2 work steps describes specifications for materials and construction. And now it is again planning of structure, design plans, design of structure, design drawings and other materials, construction of structure, as-built drawings and reconstruction, maintenance of structure, specification of maintenance plan, investigation, deterioration, prediction and evaluation, then remedial measures required or not, and one is recording, one side is assessment, and then implementation of remedial measures, records and storage of maintenance records. That's figure 4 work steps described in specifications for maintenance. Technical skills required for responsible engineers should be defined according to scale of work, importance and difficulty of planning, design, construction, maintenance. As capacity classification of engineers qualifications authorized by EJC are listed in table 1. Qualification of for special senior engineers and senior engineers are generally required for responsible engineers. JSC technical qualifications cover several fields. Responsible engineers to be deployed in projects need have qualifications only for major fields related to specific projects. Engineers qualifications authorized by EJC, executive professional civil engineers. Japan's leading civil engineers with high level knowledge and experience in its field of specialty, or with comprehensive civil engineering expertise. Senior professional civil engineer with high level knowledge and experience in multiple fields or with comprehensive knowledge on civil engineering who can solve key problems as a leader. Then professional engineer with knowledge and experience at least in one special field who can carry out tasks at his or her discretion. Then associate professional civil engineer with required basic knowledge who can carry out assigned tasks. So one is executive professional civil engineer, then senior professional engineer, then professional civil engineer, then associate professional. Executive top Japan's leading civil engineer with high level knowledge and experience in field of specialty with comprehensive civil engineering expertise. And then system for engineering reliability, ensuring reliability, how to ensure that, that's point here. Many groups are involved in planning, design, construction and maintenance of structure in order to ensure that high reliability of structure in each work phase. Organization involved should play their respective role, providing their know-how and assuming due responsibility. To ensure reliability in design planning phase, 2 independent groups should basically check design. After design and check by design company, engineers of contractors should recheck design or request a third party to check design. And fully skilled engineers should be selected for checking so that safety or other reliability parameters may be satisfied. Design drawings serving as a basis for constructing should carry signatures of responsible engineers of 2 groups that assume responsibility. In construction phase, reliability is ensured through quality management by contractor and quality verification by inspector independent of contractor. Inspections have generally been conducted directly by owner or consultant. Completed structures should be inspected wherever possible. If inspecting completed structure is impossible, inspection should be conducted while structure is being constructed. If owner cannot directly inspect structure under construction, owner may request an agent independent of contractor. Adopting as many highly reliable methods as possible can reduce labor required for quality management and inspection. In cases where adopting not so reliable method is inevitable, level of quality management should be raised or inspection should be conducted more frequently to improve reliability. Inspection items and decision criteria should be specifically presented at time of contracting because they greatly affect quality of structure and construction cost. Ensuring safety requires regular investigations. When defects are detected, decisions should be made as to remedial measures for decision making concerning remedial measures for extremely difficult deformations. Listening to opinion of engineers with high skills who have experienced numerous cases is important. In order for a system for ensuring reliability to work properly, people of organizations with technical skills fit for specific work should be granted explicit responsibility and authority and assigned to work. Compensation for work and time required for work should also be provided. General requirements. This is chapter 1 now, general provisions. Standard specifications for concrete structures, materials and construction, general requirements, hereafter referred to as construction. What it says? Materials and construction. Materials and construction, general requirements, hereafter is construction. General requirements of specification describes basic concepts for construction of concrete structures, specified in designs and specification. As a general rule, to construct a concrete structure is necessary to develop a construction plan based on design drawings and specifications. Construct structures in accordance with construction plan while performing proper quality control and inspect structures to confirm that structure has been constructed in accordance with design drawings and specifications. If it's not possible to develop a rational construction plan in accordance with design drawings and specifications, it's mandatory to revert to design stage and modify conditions set out in design drawings and specifications. For ordinary concrete works, it's advisable to refer to standard specifications for concrete structures, materials and constructions. Construction standards, hereafter referred to as construction. Construction standards of the specifications and standard specifications for concrete structures. Materials and construction inspection standards, hereafter referred to as construction. Inspection standards of specification for concrete works described in standard specifications for concrete structures, materials and construction. Special concretes, hereinafter referred to as construction. Special concretes of this specification, a construction plan shall be developed and refer to provisions of construction. Special concretes. Now some commentary. Construction. What is general requirement of this specification? Describes basic concepts for developing a rational construction plan and carrying out construction work in accordance with construction plan in order to construct a concrete structure specified in design drawings and specifications on the assumption that that structure has been designed appropriately so that performance requirements for structure can be met. Design drawings and specifications for a concrete structure, which are result of design developed, meet performance requirements for structure, show structural drawings, reinforcement drawings, concrete properties and materials, mixed proportions and other details needed to meet these properties. Its basic requirements, therefore, to plan construction of a concrete structure in accordance with design drawings and specifications. In cases where a construction plan can be drawn in accordance with construction standards, construction spatial concretes of specifications, it may be assumed that concrete structures described in design drawings and specifications can be constructed. We have listed scope of construction, section of the specification, flow of the construction process. A construction plan drawn up in accordance with design drawings and specification must be confirmed and approved before construction is started. All tasks in construction process must be performed in accordance with construction plan after proper quality checks are done at each stage. Completed, the structure is taken by owner after it is confirmed through inspection that structure has been constructed as designed. Conditions assumed for construction planning at design stage may differ from actual construction conditions. In such cases, conditions such as selection of materials, mixed design and plans at each stage of construction are altered to extend that properties indicated in design drawings and specifications are achieved. If, however, it is difficult to develop a rational construction plan while achieving properties indicated in design drawings and specifications, necessary to return to design stage and alter design and prepare new design drawings and specifications so that performance requirements for structure can be met. Construction standards of this specification apply to ordinary concreting that involves few or no special requirements. Construction inspection standards of the specification have described an inspection system corresponding to such concreting. If these requirements are met, it may be construed that requirements described in construction and general requirements of the specification are met. Construction special concretes of the specification deals with type of concrete that have proven performance based are not covered by construction. Construction standards of this specification is therefore necessary to fully understand indicated requirements, incorporate them into construction plan. And it says design starts with design, goes to construction planning, and goes to confirmed, approved, both. And then comes back in dotted line also. So confirmed, approved, after that is yes, and construction goes on, construction along with quality control, and then inspection goes back to construction. And then goes down also if it's yes, that's and maintenance you have to do, and then it's what to do. So scope of construction requirements, general requirements, and flow of concrete structures, construction processes. Now I think we have to hold on because I cannot heat up your mind. Really frank, I cannot heat up your mind all the time. And we are here also on Qatar specifications where we hold in, but we have generally got this file luckily, and I am now interested to move on both, not one alone, both we have to move. And we have to see where it's gone. I think I missed it, right? No, it's not missed. Somewhere it's here. Oh, it's here, yes, it's here. Quotation by quality, where is gone? Right? Loss of file, is it? Where's no, it's here, yes, here. Now this file, I'll move on, and we go through that to see what actually there is, how much it is down. Just for it is chapter 2, construction plan. That's construction plan, then we'll, it's good flow of better to understand. Construction plan, except considering construction plans, there are, so we will concentrate on this later, it's important. And we have to see all details are there, it's all text, no problem, you can read that. Some formula is there, we'll go to see how it's that. Following criteria used for verification, okay, we can see that one. And it's not a big deal. And here we can say construction, chapter 3, and chapter 4 is quality control, and it will be long one. Of course, chapter 5 is inspection, the part of quality control. So you may say inspection plans, okay, that's fine. Inspection, how to do inspections, maintenance inspection records, construction records, we can say you can do that way. I'll use this construction standards. I think pages are many for just blank. A general and chapter 3 general. Let us see how does it work. So I think it's useful file as far as the concrete is concerned, and we should learn something from this. Examples of calculation of fineness modulus. Okay, that's fine. This is all right. The definition of powdery metal, pine and cement. Okay, I'll see that one. I think it's good technical work here, which engineers don't do actually. Quality of concrete. It's good, I think. It's a good book. So we'll see something. Maybe we got new in Japan specifications. How this work. Relationship in specified slump at each stage of construction changes in slump over time. Example of compaction height, impaction of compaction height in case where a construction worker enters the formwork for a concrete member. Pumpability, and we'll see how does it work again at this point here. I think it's an attractive file. Let me see what time is now. 2 hours 46 minutes. So I think we have to close a few minutes. So we have many days to study this, and it's good. I think it's good knowledge. I'll try to extract something from this constituent materials for posting purpose. I think it's ongoing. I'll let him blow up directly because it will take a lot of time. Injection tube, okay, this is a repair. Hot weather concrete. Hot weather concrete, 25 degrees temperature is mentioned here, and doesn't exceed 30 degrees. So this is hot water concrete. I'm just browsing it to know what is there. I think it's interesting. It looks interesting, and we have to understand it properly as well. Well, that's a long way to go. Chapter 6 concrete. ready mix concrete. Okay, for chapter 5 there are 9 chapters, so it's halfway. Well, we'll see this one. We'll look into this. It looks interesting, and we'll look into that one. Now, what actually we have to say, we have to think of now. What we have. I'm now back to this one, and Qatar concrete also, and also we can say quality issues that we're talking of, and quality issues we're talking of here, and of course this is our certifications and quality here. We have to find any red lines. Now these red lines are can be changed now. Some of the lines that we have to see very well, and we understand that it can happen, and we know, so we will take care of this in this coordination file. So what we are expanding our coordination through these specifications actually, because all this is coordination, nothing else. You may call it technical work, you may call it interrelated technical work, you may call it coordination work. You can call it by whatever name, that doesn't matter. And of course, it's interesting to know that technical work is very important, concrete is very important. If you take care of that one, it's very important one. We cannot say no, yes, but same we have to understand it properly. And I think design is also important here. Designer has to read this if they have a chance to read this. If they cannot do, that's something up to them, but it's the part of design itself to read the specifications, to know how we do what we do. It's also a part of design specification. How many pages are there? We see lightweight aggregate concrete, and it's itself a good subject. You see, maybe we have same in 456. I'm not sure what's 456. I'll just give you. If I search for 456, what we got, I don't know what. Let me see if I can find something in 456. Let me see if we can get something here. Maybe I'm not sure. I guess 456. 456. Let us see how this is answer. 456 2000 it is, and it's only 2000. RIA from 2005, and revision 10th April 2007. It says 2005/7. Is something updated on that? I don't know, but let's see what it says. 2000 Code of Practice I September 2013. Well, I think again 2013, and I saw the PDF download itself to this 2020. 2020, I think we will ECL search download this. I just for the practice in Indian Standard Code of Practice, general structure is plain concrete. So we can say, says insta pdf.com. Let us see, let's try 2020, what does it say, and let us see how to say. Maybe it's more useful. It's again, it's not download what PDF. This is download. Let's say internet monarch, and this is of course download. You can download it now. It's downloaded, and first download it is. So it's ready for download. So I think it's downloaded. It is it ready? Get this execution to 3.9 MB. It is. So it's come. I think nearly come. So we got it. We can say we can download it now. We can get it media, and we can say it's coming. I think it's coming. Just wait a minute and we'll see how long is this. How many pages are there? I already know that. It's executive file. I cannot get. I think. Why is that? Why it's not coming in? I told reason for that. Why it's not coming in? I downloaded it. It's not coming. What's the problem? You can close it, is it? What's not coming in? It's not coming in. That's the problem with this. I think they don't want to give it to others. That could be reason for the download. Download, it's not coming in. It's not coming in. That's a problem. They say download. How to download? It's not coming in. So it's downloaded, but it's not coming in. It's not opening. errors, only errors. Fuck off, I don't know this. Only people nonsense, they talk nonsense only. Free download on this. Again it's saying that for download. When download is not coming up. Same thing has happened, it's come again, same thing, field virus detected. Okay, it's detected virus though. Maybe it's just same thing, virus detected. Okay, virus is there, close it there. It's giving me same answer, virus detected I think. So it's due to virus, it's not opening. So let us see what is happening. Hello, potential unwanted application is blocked to perimeter system. Processing location use media get allow no okay remove I don't allow this Kali I don't just take risk for nothing. For what? I don't take any risk, leave it. I don't take I will realize some other way. Waste of time, nothing else. Okay, we go now back to our system. I could not get successful. I wanted to see that, but I'll try other time. And this is my file. I close this file also today, so that we see now back to few minutes only left, 3 hours, and we see what to do. I tried my best to get something, but I cannot get a waste of time because sometimes this is something we have to. So we have 2 files now: SCAR section 5, this concrete, and also we have this Japan file. We'll concentrate on these in addition to our issues of quality and issues of these issues of quality and issues of coordination. And it's very important really to understand, to see how we can do. And our issue is quality and coordination, and this is a part of coordination. We are trying to get more and more information, not only about works coordination, but also material coordination. Concrete is a material, very important material, very expensive material, and we cannot do without this. And how to coordinate activity on materials, that's also important point. So we have to be very careful about this, means what we say, what we do, and we have to understand facts. In fact, facts are very important, and we have gone through quality issues, and in fact we can say quality in coordination is also important, because without the issues of quality, whether it may be quality system, or it may be quality requirement, or it may be quality controls, or it may be system quality, materials is very important part of that. Material, and concrete is a dominating material on which depends all other materials. If concrete is not good, it's not reliable as is expected, then we can say all other materials which are placed on concrete horizontally or vertically, whatever way, won't work if concrete does not work. If concrete fails, these also called finishing items should fail. And it's not only finishing items, it's also users fail, because maybe it results in accidents sometimes. Those points we have to very clear. So concrete material is base material, we can say, in structures, and concrete is life of structure, life of that whatever we build, and that project, or that life of that unit, that is very, very important from every viewpoint, and we should not take for granted. I will try to get download of 456 daytime. If I can get successfully, we got a copy of that, and I want to see how much, how long we have gone in concrete, or we are still beating about bushes as we used to do in our country. So I actually entered into a lot of coordination on this talk due to certain reasons. I discovered that coordination is very poor in our country, and this means quality is also very poor, and we can see this projects. There's no quality issue considerable, People do their own way, they don't bother about anything. Engineers are there millions in our country, but what's meaning of the engineers if quality is not maintained? And they may give any excuse if you talk to someone, but real excuse is we do not care. We are sleeping society as far as quality is concerned. And that's my observation. And with that observation, I try to close this file in a couple of seconds, in a couple of minutes, just to think how to do help. And you can also write to me suggestions what we should do. But it's for public. It's not for me or for engineers alone. I want to inform public what happens, how does it happen, and we have to interact with people if people can demand that. It's a very important point in life that nothing goes on without it. Therefore, my dear friends, I don't think that's waste of time. It's very important time, and I'm not interested. I'm only interested. Standards should rise. I've seen very good standards in my career, but here I can't see rusted steel being used. I can't see without any compaction work is being done. The compaction of soil. I can't see curing is not cared for. Really, it burns me when I walk on road and see such things, such bad actions are not happening, and nobody is there to care for them. Nobody bothers about anything. I feel pain, in fact, and that's why to share my pain, I come to you to talk to you as public as well as engineering community, both, and because public is more important than engineering community, because it is engineering community to solve problems of people, but otherwise it's happening, and that's very important point. I have to think of, and we all have to think of, dependently or independently, whatever way, coordination. We otherwise, it's very very important. Really speaking, with this, I think we have to take your leave today. Of course, some time was wasted due to some reason, but that is natural because I also want to go to toilet and to take some water. That is natural, and I think you will agree with that. These files which I try to show to you are important ones, and these files can't be compromised with. Quality is main issue, and we have to raise this question all time, that can we bring working environment to quality, and coordination requirements, if yes, how to do it, and in coordination what to do, how to do. That's the point here. We have to explain to ourselves what is our role in this. Coordination engineering is a must on every project, and nobody can deny that fact. And here we have to think of how to improve these issues. And if you don't improve, who shall improve? That is point number one. We shall improve. That is answer point number one. But does it happen? It doesn't happen. And that's why it's very important to concentrate, to focus on coordination and quality. And if you try that, of course it's very difficult, I know. It is something you have to evolve yourself, somebody help you. That's point of view. Besides, thank you very much. I'll meet again to you. Thank you. Bye bye.